Tuesday night, 9th of July, we have a 4-day moon, almost due west of here. Shouldn't have much impact on the sky. Seeing lots of atmospheric smoke, I suspect. Don't know the source of the fires. I don't think we're going to get the greatest views tonight, but there aren't too many more opportunities to do deep sky. And however, the kinds of studies we're going to track down tonight are probably going to give better views than most. They will be globular clusters. So let me go ahead and set up the scope. It's about 10 o'clock in the evening. Probably not going to get much darker than this, largely because of the transparency. Largely because of the high thin smoke, in this case, not clouds. While the night's going to primarily feature globular clusters, it's always nice to start off with a view of an easily recognizable study. Here we have what I call a 3-inch equivalent view of the Ring Nebula, Messier 57. I'll step through it a little bit. Now we have, the previous view is what I call, like I said, a 3-inch aperture view. We'll go to 8. That means whenever you double the shutter speed, you basically divide whatever aperture you believe was the baseline aperture in half and add that to the previous aperture. So now we're probably at about 4.5-inch view of the ring. 16 basically is doing that again, what I call a 6-inch view, and that gives a particularly nice look at the Ring Nebula. However, tonight I want to feature 9-inch studies. So if we go to 32 flood, we leave it right there, we're going to go through our list of about 20 globular clusters, if feasible. Some will be deep, deep south, and we will have a look at how they present. Well, that's a pretty good view. I'm seeing the central star, and it's hard for me to understand why we're seeing it under 32 flood or the 9-inch aperture view. Very peculiar. But one of the things you'll notice about using faster shutter speeds is the image will develop very quickly, although it won't be nearly as deep as you might expect. But it will also give a better aesthetic in general because there won't be as much background light. Now, I can't do anything about the artifacts. They're just like tiny little bright dots on the screen. You'll see them reproduced over and over again as we look at different studies. But the Ring Nebula has a nice neighborhood of stars in it. So there is our view. And I'm going to save this view out for the evening studies because I want actually to feature what I consider to be probably the optimal aperture for scopes that you'd want to use if you wanted to particularly explore globular clusters in the sky. So if you had a 9 or a 10-inch scope, typically it would be an SCT, possibly a Newtonian, but mostly SCTs come in that range, 8 to 10-inch Schmidt-Cassegrain telescopes. This view of Messier 57 and the globular clusters to follow would probably be just the right kind of deep sky studies to hold your interest. So this is a 75x view of Messier 57 as it might appear through a 9-inch telescope. Okay, what you're seeing here is, fortunately, the scope is getting a little aperture block. So we're only getting about half the aperture. But that's not a bad look. Messier 13, the great cluster in Hercules, can give a fairly decent view at lesser apertures. So this is our view, and as I said, we're getting some aperture block due to the roof try, but I'm actually quite impressed with how attractive Messier 13, the great cluster in Hercules, looks. We will also make a run at Messier 92. These are all warm-ups because just about all the clusters we're going to track down tonight are going to be NGCs, and they're all going to be deep south, so we may not get particularly good views. I wouldn't expect to see much that looks as nice as this. Okay, here's our view of Messier 92, and Messier 92 is also getting partial aperture block. But once again, that's a very decent view. So the only thing we've really seen so far is roughly a 9-inch scope equivalent aperture using the set points of, I believe it was shutter speed of 32. Yes, indeed, 42 decibels gain has been the Ring Nebula. So let's move on to Messier 56, and I'm sure we're going to get full aperture on that. But I don't think it'll be quite as attractive as this view of Messier 92, and certainly not as good as our view of Messier 13. Here we have a fairly decent view of Messier 56. I've noticed in a 6-inch scope under very good conditions, you can sometimes resolve maybe a half dozen of its components. I'm not sure Messier, when you go through the Messier catalog in the controller unit, the Gemini 2 controller, it gives you any data. But typically when you go through the NGC catalog, it will tell you the magnitude of the brightest stars in a globular cluster. I will give you the data on Messier 56 just in case they do include that information. Unfortunately, when you go through the Messier catalog, you do not get the equivalent NGC number. So I'll give you the data. Messier 56 globular cluster in Lyra. It's kind of between Lyra and the beak of Cygnus the Swan. Magnitude 8.3, 5 arc minutes in size. More distant than the M13 and M92 at 32,900 light years, but in a nice position in the sky at plus 30 degrees, and that's an attractive view. Why don't we have a look at Messier 4 next? Here we have Messier 4 in Scorpius. So we've covered Hercules, and we've covered Lyra, and now we're deep south in Scorpius, very close actually to Antares, the rival of Mars. One thing I would point out about Messier 4 is I generally use it as my standard candle for comparing other globular clusters to it. It's not a particularly bright cluster, although, I mean, in terms of intrinsic brightness. However, it's only about 7,000 light years distant. It's magnitude 5.4 and 26.3 arc minutes in size, but we're at minus 26 degrees, pretty much pushing the lower limit that I like to go into, although I will turn up some studies as deep south as 37 degrees if they're culminating, and there may be a few clusters like that this evening. So, now having imaged several Messier globular clusters, I think we're going to go ahead and start seeing if we can track down some of the NGCs that are on my list. Unfortunately, the color pen I use will make it rather difficult for me to read what I've written down, but I should be able to pull it off. Messier 4 near Antares in Scorpius. Okay, what we probably won't be seeing here is NGC 6380, a globular cluster in Scorpius. Magnitude 11.5, 3.9 arc minutes in size. Its brightest stars, because I'm now referencing the NGC catalog, are magnitude 17. Cluster is about twice as far away as Messier 4 was at 13,000 light years. We're at right ascension 173428, which is okay because that's almost culminating right now. Unfortunately, we're also at declination minus 390409. I am not seeing anything on the screen. It's just helpful to know about it. The scope, however, is fully, the aperture is fully above the south-facing wall of Pentity Observatory, although I cannot be sure that we aren't being blocked in some way by some leafy vegetable types that are in the line of sight. Anyway, so I thought I'd at least tell you about NGC 6380. Okay, while I picked out most of these globulars initially from the Sky Guide, I also am stepping through the NGCs in the catalog to see if there's anything adventitious. I had selected NGC 6388, but it was almost minus 40 degrees in declination. Here what you're seeing is an adventitious globular cluster, NGC 6401 in Ophiuchus, magnitude 7.4, but incredibly small. It says here 1 arc minute. It's a type 11, so it's also quite diffuse. 24,000 light years distant. It's at right ascension 1738.36, declination minus 23.54, 32. It is visible on the screen, but we are fairly deep south, although we should get a fairly decent view should the cluster have been as bright as it is said to be, magnitude 7.4, and is condensed 1 arc minute. The data on this may be a bit off. Do your own research. NGC 6440 is a rather brightly condensed globular cluster in Sagittarius, magnitude 9.3. You can see why I was suspicious about the last one. 1.7 arc minutes in size, with its brightest stars magnitude 16.7. Can't suspect, ordinarily if I were operating at 128 flood shutter speed, we'd be able to resolve very faintly some of those stars, but we're operating under 9-inch parameters now, and the brightest stars we would ordinarily detect at that aperture would be somewhere around 14 to 14.5. This is a class 5 globular cluster, 26,000 light years distant, so at about the same distance as the Great Hercules cluster. Right ascension 1748.52, declination minus 20, 21, 38, and there is an obvious view of NGC 6440. Here we're having a look at NGC 6441, another globular cluster. This one's in Scorpius. Brightish, magnitude 7.4, largest 7.8 arc minutes. The brightest stars are magnitude 15.4. Once again, I don't expect to resolve any of them. This is a class 3, so fairly compact and bright, 32,000 light years distant. Right ascension 1750.13, but its declination at minus 37.03.03 does not exactly give us the best vantage. However, the cluster is quite obvious right there, of course, right? No, of course, it's right there on the screen. NGC 6441. Once again, I remind our watchers that we are looking at the sky through a 9-inch equivalent settings. We're also deep south. And we are studying globular clusters in particular. This is NGC 6453, globular cluster Scorpius, faintish, magnitude 10.2, 3.5 arc minutes in size, a class 4, so towards the more condensed end of the spectrum of globulars, 36,000 light years distant. We're at RA 1750.51, but our declination is pretty deep south, minus 34 degrees, 35 minutes, and 54 seconds. And I would say that about the faintest, well-positioned globular I've ever seen at the eyepiece of a 6-inch scope was the Intergalactic Wanderer, which is in Gemini. So this is a better view. You can see it right there on the screen. And we're also deep south, so kudos. Night sky is probably better than I thought originally. What we have here is NGC 6517, a small, faint globular cluster in Ophiuchus. Magnitude 10.3, described as being 1 arc minute in size. Brightest stars are magnitude 16, a class IV or 4, 34,000 light years distant. We're now past 18 hours in right ascension, 180150, and our declination's a little bit further north. We're at minus 8 degrees, 57 minutes, and 31 seconds. The cluster is quite apparent on the screen. NGC 6522 is a deep south globular cluster in Sagittarius. We're at minus 30 degrees and change. Magnitude 9.9, but larger than most of the 10th magnitude proximates. 5.6 arc minutes in size. Its brightest stars should be within the range of a 9-inch scope, so you should get some resolution. Magnitude 14.1. It's a class 6, 23,000 light years distant. Now, we are pretty far south, so we'll have to check the screen tomorrow to see if we've actually resolved some stars. Ordinarily, at this minus 30 degrees, I wouldn't expect to be able to resolve any stars, even through a 9-inch scope, any brighter than magnitude 12. So if we're seeing anything up there, it would be very suspect. Anyway, have a look. NGC 6522. NGC 6528 is another one of those faintish globular clusters in Sagittarius, also pretty deep south at minus 30 degrees and change. This is a magnitude 9.5 globular, 3.7 arc minutes in size, with its brightest stars magnitude 15.5. It's a class 5 of 12, 24,000 light years distant. We're at RA 180449, declination minus 300321. And it's fairly apparent on the screen. NGC 6535 is a globular cluster in Serpens, magnitude 9.3. 1.3 arc minutes in size. Brightest stars, however, magnitude 12.8, and we should be able to resolve them. But I'm really not seeing much of this cluster on the screen. Although I do believe it's in this region here. It must be a fairly diffuse cluster, and there are individual stars apparent. It is a diffuse cluster. It's a class 11 of 12, 22,000 light years distant. RA 180350, and declination pretty much spot on the celestial equator at minus 17 minutes and 51 seconds. So, resolvable stars, magnitude 12.8, should be able to make those out, I believe, in a decent 6-inch scope on a good night of seeing, and we are seeing a peppering of faint stars, but without any sense of a condensed nucleus in this globular cluster, 6535. NGC 6539, another globular cluster in Serpens, magnitude 8.9, smallish, 2.5 arc minutes, brightest stars are magnitude 15.9. It's a class 10, 26,000 light years distant. Once again, it's not very condensed. You can make out some sense of faint stars there. That's interesting because the brightest ones are magnitude 15.9. We're at right ascension 180449, declinations minus 735, E11. And like I said, there's just some hints of nebulosity there. Which should be visible stars, but not at magnitude 15.9 at these 9-inch settings. NGC 6540 is a globular cluster in Sagittarius, which should not be visible on the screen. It's magnitude 14.6, 0.8 arc minutes in size. It's a class 11, 11,000 light years distant. Right ascension 180608, a declination of minus 274550. And you know what I feel like doing with this one? We're not going to carpe noctem out on it, but what I'm going to do is I'm going to bump the settings so we can watch it develop more fully on the screen. It's in a nice starry field. This will be a nice opportunity to compare the aesthetics of backgrounds and how much detail we can bring out if we allow our exposure times to increase. So this, I will show you once again the settings. Pushing the wrong buttons here. Okay, so that's 32 flood. Remember, that's the 9-inch settings. If we go to 64, that should be roughly 12-inch settings. So we'll let it develop a little bit. I may have to reposition the cluster in order to be able to see it on the screen with the shutter speed text such visible. But I do believe the cluster, if it's anywhere, is in this little region right there. So now we're up to about a 12-inch scope, because we're pretty much 4 times what the 16 flood was for a 6-inch. And anytime you increase it by a factor of 4, you basically doubled the aperture. Let's try 128. Now, once again, I want to point out that it takes a little bit longer to assemble the image. And I do believe the cluster is revealing itself on the screen. And the highest setting we can go to, so at 128, we basically taken 64, which was the 12-inch setting, we doubled it, so we've basically added another 6 inches to 18 inches. Sometimes I assume it's about 20 to 24 inches. I'll have to give that some thought. So 16 to 64, yeah, 64. All right, so let's just assume it's about an 18-inch scope. We'll push it up to the maximum of 256 flood. Now keep in mind, we're at minus 27 degrees, 45 minutes, and 50 seconds. We are looking at what's supposed to be a magnitude 14.6 NGC 6540, globular cluster in Sagittarius, less than 1 arc minute size. It's a class 11, 11,000 light years distant. There are no indications here about what its brightest stars may be, but given 14.6 magnitude in its class, I'd say its brightest stars are probably around magnitude 18.5. So there's our look. I'll drop back down so that we can resume our 9-inch settings. All right, let's watch how I do that. 128, 64. See if I can have it reach here. And you can see it drop down again to our original settings. And all you get is a vague sense of something that might be starry, like a small grouping of faint stars right there towards the middle of the screen. Now here we have something that looks much more like what you would expect in a globular cluster. It's got a bright core and it's got several stars that look like its members. This is a globular cluster in Sagittarius, NGC 6544. Pretty much Messier level magnitude 7.5, and largish, 8.4 arc minutes. Its brightest stars are magnitude 12.8, although it's a class 9. So a 6-inch scope under good sky conditions, and with it pushed further to the north, because we're at declination minus almost 25 degrees, should be able to resolve some of these stars in the same way you can resolve them in Messier 56, except the sky position here is much lower. So there's our look, NGC 6544. What we're seeing now is a very distinguished globular cluster, and it's probably on the Messier list, although it's not indicating it on the handset. NGC 6553's globular cluster Sagittarius, certainly Messier brightness, 8.3, a little smaller though, 3.2 arc minutes. Its brightest stars are magnitude 15.3. And I did revert back to the 9-inch settings. We are getting some hints of resolution, but I don't think that's really the case. It's just probably pixelation. This is a class 11, 15,000 light years distant. Right ascension 1809, 17, declination minus 25, 54, 30, and there it is, a very nice look. Should give a good view for a 9-inch scope, as I have mentioned from the beginning of our series. It would appear we are now back to our smaller, fainter NGC class globular clusters. This one is NGC 6558 in Sagittarius, a little too faint for the Messier catalog at 8.6 magnitude, 3.7 arc minutes in size, 21,000 light years distant. We're at right ascension 1810, 18, declination 3145, 47. We are getting with the sky drift, sidereal motion. This one's pretty close to culminating, and thankfully that's the case because of our declination of minus almost 32 degrees. The cluster is quite apparent on the screen, although not particularly distinguished. What we're seeing here is clearly a globular cluster. It's on the Messier boundary, NGC 6569, globular cluster Sagittarius, magnitude 8.4, 5.8 arc minutes. It's a class 8 of 12, 28,000 light years distant. Right ascension 18, 13, 38, but the view is kind of limited by the fact we're at almost minus 32 degrees in declination. However, its nebulous aspects are quite apparent. There's no published magnitude of its brightest stars, however, but fairly, despite being a class 8, fairly condensed. So as we watch this cluster develop, I want to point out that I covered all the clusters on the handset that were accessible, with a few exceptions that were down to like minus 40 degrees in declination, from about 6380, I believe it was. And I pressed adventitiously through the catalog up to 6600. What we're seeing here is a globular cluster Messier 22, which is actually probably the brightest cluster that you can see in the northern hemisphere, although Messier 13 probably gives a better view for most because it is north of the celestial equator. I'll give you the data on Messier 22. It is a globular cluster in Sagittarius, magnitude 5.2, 24 arc minutes in size, but it's only about a third of the distance as Messier 13. This is 10,400 light years distant. I believe 13 is about 26.4. We're at right ascension 18 hours 36 minutes 24 seconds with a declination of minus 23, 54, 12. That is a very, very present view of a magnitude 5.2 globular cluster, Messier 22. Carpe Noctem.